Alright, hello and welcome back. In this video, Lee is going to start laying down some of the groundwork for our worker threads. So Lee, why don't you take it away?
All right, we're going to be doing our interface and abstract class for our worker thread. This isn't going to be implementing any functionality that we can demonstrate in this video yet. We'll get back to that, but that's why the last video I wanted to do the demonstration of what a worker thread is and how they work.
Okay.
In this video, we're going to be putting together an interface that our worker thread is going to implement, and then we're going to build an abstract class that is going to put in the base functionality that all of our worker threads are going to inherit from.
Okay.
And the reason that we're putting this together now is in the next set of videos, not the next video, but the video after that, I believe, we're going to start putting together the threading pool. And we want to make sure that all of our worker threads that are created for whatever we decide to use this threading system or threading pool system for all work in a consistent manner, that they're all going to have the same fields, the same properties, and the same methods, and they work pretty much the same. The work that they do in of themselves can be vastly different, but how they approach getting that thread started, running that thread, stopping the thread, cleaning up after itself is consistent across the board, which is why we're going to use an interface and abstract class. So let's go ahead and start coding this up. Go over here into threading. We can add a new interface. So apparently I can't add through there. Control-Shift-A will let me do it. Come on. Add new item. I apparently no longer have the ability to add stuff here.
Is it, well, no, I don't know.
That's going to cause a bit of an issue. And hold on a sec. That might be because I'm still running the application from last time.
I won't tell anybody. We'll just play that off.
Nobody saw it.
Yeah.
You know, and nobody's going to see this video either.
Anything.
That was by design. In case you ever go to add something and it's
Right.
all grayed out.
Because it's important for us to teach people new things. You might not realize that sometimes when using Visual Studio, it will not let you add a new item. In that case, one of the first things you should always check is that you're not still running the application there. I think we played that off smoothly enough. Let's continue.
Yeah. Okay, cool. All right, so new interface. This is going to be worker thread. So there's our worker thread. We'll do a little bit of cleanup, just like before. So looking at the namespace to make sure I stay consistent. Matter of fact, just to be safe, I'm going to copy the whole thing. Oh, I could just delete this too. There, look at that. All right. We've got our interface. We want to make this public. And we're going to need three things inside our interface. We're going to need a Boolean. This will be is alive. We're going to set this as a read-only property. This guy's job is just going to be a Boolean that indicates whether or not the thread is still alive or if it's stopping or stopped. We're going to have a method that's going to be our start method. This is going to be the method responsible for starting our thread. And then we're going to have a stop method, and this is going to be the one that we're going to use if we need to stop our thread. Now, this is the base functionality that we've got. There's going to be some more stuff that we're going to do with this later, but it won't make sense until we get to the threading pool part of our implementation. So I've moved it out, and we'll come back and we'll add some more stuff to this when it makes sense. I'm going to go up here and hit Alt-Enter to clean that up.
Okay.
So that'll get rid of this. So that's our interface. We need an abstract class to go with it, and because we're not running the program, I'm pretty sure I can add it now.
Well, it wasn't grayed out. That's a good start.
Yeah, well, that's the start. All right, now this will be our worker thread class. Again, some initial cleanup. And because this is an abstract class, we need to set it as a public abstract. Well, we need to set it as abstract. It doesn't have to be a public abstract. We're just going to make ours one. Now, we're also going to tell it it needs to enforce the iWorker thread interface contract. So I'm going to tell it to do that, and we're going to get an error that basically says we haven't implemented all the methods that we need to enforce that contract. So I'm going to implement those members. Those are our start and stop and is alive. So go ahead and hit finish. And that'll put in the basic part of this. Now, for is alive, well, let me clean this up first, then I'll come back and explain what these ones are going to be. Because I don't want to throw the exceptions. Now, is alive is responsible for telling whether or not this particular thread is alive. We don't have a thread yet. This is an abstract class that is pretty much a wrapper around our thread. So we need a thread. So we'll make a public, move that down a bit.
Yeah, I was going to ask.
Yeah. Once again, looking at my keyboard instead of the screen.
I won't comment on that.
We're going to make a public thread, not threading, thread. Wow. Alt-enter to implement threading. So public thread called myThread. And we're going to give this a getter and setter. Now that we have a thread, we can return whether or not the thread is alive. What we're going to return is going to be return my thread, and it is a live boolean already built into it. That's what we're passing out. We're basically just passing out what our threads is alive flag is set to, because this is going to be our wrapper to our thread. We're basically encapsulating the starting and stopping of a thread inside of this abstract class. So inside of start, just like when we did the demonstration of a worker thread, we have to create a new thread, and then we have to tell it what that thread is going to do, and then we have to start the thread. So we would go my thread equals a new thread, and that thread needs a method. We're going to call this particular method onRun. And just for fun, I'm going to give it a name called worker thread. And you can see we've got an error because we don't have a symbol for it yet. And I want this to be a method. Do I have the ability to create one from here? And no, won't do that. All right, I'll have to do it by hand. All right, so our onRun method is going to be a private void onRun. It's not going to take anything in. And the only thing that this thing is going to do is going to call another method. The method that this is going to be a protected abstract method that returns nothing but is called run. And apparently I spelled protected wrong.
Yeah, you dropped an extra C in there.
Well, you know, 1 C is good, 2 must be better, right?
Exactly.
All right. There we go. Protected. So basically, we have to, or we can override this when we inherit. Now, on run is going to call run. Now, why would we want to do this? The reason why is we want to define the functionality that is going to be run by the thread inside of
hang
run.
tight just a second, Lee. You're breaking up just a little bit.
Okay.
Give that just a moment to resolve. Actually, what I'm going to do is just pause the video for just 1 second. And we're back. We just needed to give Skype a second to catch back up. So, sorry about that. Please continue.
Yep. Okay, no problem. The reason
Nope.
I believe did it break up again?
Yep, as soon as you started talking. Let's just roll with it. I think it'll be okay.
Okay, yeah. You know, those bits take a while to get from the East Coast to
Yeah.
the Tennessee. But what we're doing is, with an abstract method, anything that inherits from worker thread is going to be able to override this functionality. This is the functionality that we want this thread to be able to run. We also want whoever is implementing the derived class's functionality to be able to define.
Okay, sorry. You got to hold up. We're losing it again. I'm going to try pausing it. Okay, sorry about that. We're back. Just a little bit of an interesting connection issue with Lee breaking up a bit over Skype, but we should be okay now until it happens again.
Well, you know, I'll just go over it again because I'm not sure how much broke up or how
Yeah,
bad
that's
it's really
probably
broke up.
safer.
So, but what we're doing is, or what I was explaining before, you know, we got really interrupted with static, is we want whoever's implementing the derived class from worker thread to define their functionality that they want this thread to run inside of this run method.
Mm-hmm.
Now, we can't tell our thread to run an abstract method. It has to run something that is part of this and defined inside of this implementation of the class, which is why we created the onRun method. The onRun method, however, can call this method.
Right.
So we're telling the thread when it starts to call onRun. onRun is going to call run. Run is going to call this functionality, but this functionality hasn't been defined yet. We don't know what this functionality is. We don't have the ability of ever knowing what it is at this point. This won't be defined until whoever implements this basically little API that we're building decides to put in. So that's how we're going to deal with starting or defining our thread. Once our thread is defined, we can call mythread.start, just like we did with the worker thread demonstration. We're doing pretty much all the same functionality we did before. We're just encapsulating it into an abstract class and an interface that can be defined by anybody, instead of forcing them to have to figure out how to do this on their own. Now, once we stop stuff, we had to mention that we would like to be able to stop it. Now, one of the ways that I mentioned that we could stop a thread is using a flag, putting our functionality inside of an infinite loop, or a seemingly infinite loop. It wouldn't be infinite if we could turn it off, but it continuously runs until a flag gets set.
Okay.
Now, we can't be sure that that is going to always happen. In other words, we have no way of enforcing the fact that whoever's deriving from this class is always going to implement that particular method of stopping the thread. So what we want to do is give them a method so that they can stop the thread on their own. Mm-hmm. So to do this, we're going to say if mythread.isAlive, then go ahead and call mythread data boards. So this should stop the thread if it is still running.
Mm-hmm.
And then we need to call stop. But this can get a little bit confusing. It's like on call stop, and we're calling stop here. This one is a little bit different, and the reason why I implemented this was just kind of, there goes with that extra C again, is just to keep the naming convention similar.
Mm-hmm.
So I'm going to make a virtual void stop method because I have a start. I have a worker thread dot start.
Mm-hmm.
I want to have a worker thread dot stop, but I've got stop already inside of iWorker thread and a start here. So I need to be able to implement this in such a way that, and this one's actually not a public, it's just a private, or actually it's just void. It's a void stop. But I want to implement this so I can call stop from my derived class, but I can also call the iWorker stop. So to do this, what I do is I make a virtual stop. We still have an error here and an error here because it's confused. It doesn't know which one I mean for each. But if I go up here and say iWorker thread dot stop, excuse me. So if I say iWorker dot thread stop and stop here, it now knows that this one, I'm referring to the stop here, and that this stop is the stop that is implemented by whoever is deriving from this class.
Gotcha.
So again, we need to have the ability to clean up our thread. We don't know what the developer is going to implement inside of their method. They could have their own worker thread, which is their worker thread is a class on of itself. So it's going to have the potential to have any number of fields, properties, data, could be anything that they want it to be. We need to give them a mechanism in which that they can start that thread. But when we stop the thread, we also have to give them a mechanism to clean up after themselves. Mm-hmm. So if they're creating a whole bunch of data structures and objects or whatnot, and they have to manually clean that up, by doing this virtual, they have the ability to override stop, put in whatever cleanup code that they know, and be assured that if for some reason the worker thread is stopped, that their code is going to be called as well to clean up after the thread's been terminated.
Okay.
So that's what this abstract class, or what this virtual method is going to do for them. It's going to ensure that it gives them a way to call their own cleanup code.
Sure.
So basically, that's all that this video was. It's just laying the groundwork for our worker thread class. Mm-hmm. And setting up a framework around a thread that will allow us to consistently be able to define different types of worker threads to do whatever we need them to do, and be able to know that you've got a consistent way of starting it, a consistent way of stopping it, and that you've got these base things that you have to implement, because all of these are going to be based off of the worker thread. That means all of these have to have a stop, a start, and the is alive is taken care of by the abstract. And start will be taken care of, well, hold on. Start and is alive is taken care of by the abstract here. But stop is handled by you, so you can put your own code in. So all you got to do is create your own worker thread, and we're going to go through that in the next video and use this so you can see how it's used. But we've got that consistent way of using it across the board.
Okay.
And that'll really come in handy once we start messing around with the thread pool, because now you've got a way of scheduling literally hundreds of different threads that may or may not all be of the same type. So in the case of the train R&D, right now the only threads that get scheduled are the creation of the train patches. Later on, this system was designed to be flexible enough to be used pretty much as is all the way through the production of the MMO. Mm-hmm. So at the very end, you might be scheduling threads for dealing with the AI, with the quest system, with caching information to and from the hard drive. That could all be handled with this one system. You give it a priority, it goes into the queue, and as threads free up, the next job gets scheduled. So we don't know what the functionality of the system is going to be, but with this groundwork in place, we don't have to know what it's going to be. It should be able to handle it all on its own.
Very cool. Well, does that wrap up everything you wanted to talk about?
Yes, for this video. Okay. I've got lots of stuff to talk about, but for this video,
of course. All right.
That's probably enough.
All right, so that will wrap us up here. Thanks a lot for watching.